In this lecture, we are going to learn about go back N protocol. Okay, so the protocol is go back N, and it's a flow control mechanism where a sender can send it to a receiver in a controlled manner, okay, which the receiver can decide. So what happens is that there was stop and wait protocol, in which the sender sends packet to the receiver, and how the flow control was maintained was that the receiver, only after processing the packet, okay, after receiving the packet, he sent an acknowledgement saying that I have received the packet, now you can send more. So this way what happened, the receiver can never be overwhelmed, because only when the receiver sends an ARQ, sender can send a new packet. So it's stop and wait. Okay, so I send a packet and I will not send any further packet till the receiver allows me by sending an ARQ. So this way receiver is always comfortable, he will not be overwhelmed by the packets. But what happens is the sender sends the packet to the receiver, okay, the channel becomes idle now. When he sends the ARQ, after that only he can send another packet. So this way the channel is not utilized much and throughput is less for this particular protocol. Okay, it provides us the flow control, but it's not that efficient. So go back N is another mechanism which has better throughput. So here what happens, instead of sending just one packet, the sender can send up to W frames. I can send, let's say, 7 frames. So 1, 2, 3, 4, 5, 6, 7. I can send 7 packets without considering for an ARQ, but I will stop after sending 7 packets. This way still receiver knows that okay, he cannot continuously bombard me with packets, but only I know that maximum of 7 packets I can receive, and after that he has to wait till I send an acknowledgement. So here it's kind of trade-off. Now I can send you some packets but not continuous packets. So you can send W frames without worrying for an acknowledgement. But what happens is that you also keep a copy of the frames until the ARQ arrives. So now you can ask the question, why should I keep copy of frames till an ARQ arrive? Okay, so I have few packets. Okay, let's say I have few packets. I send to the receiver frame 1, then frame 2, frame 3, but let's say all of them were lost, and so I had a timer here, T1, T2 and T3. So because I did not receive any ARQ, so I will know that okay, after some time, let's say the timer expired after 1 second, so I will know that okay, it was not received by the receiver because he didn't send an ARQ. Similarly for F2 and F3, frame 2 and frame 3, so I will retransmit it, and for retransmitting you need to have that packet. So it's kind of a mail. Okay, you send a mail, and then if somehow it was not received by the receiver, you need to have a copy of the mail if you want to send it again. So that's the idea for having a copy. This procedure requires, so now stop and wait was a simple protocol. Here you need a somehow to know that I can only send 7 packets, 15 packets and so on, and that is maintained by a window, okay, that we will see, and it's famously known as sliding window protocol. So each packet, because now in stop and protocol I had only 2 numbers, sequence numbers 0 and 1, because I sent frame 0 and then next time I had to send frame 1. Then when I have sent frame 1, to differentiate it from the previous one, I will send frame 0. But here there is a window of I can send up to W packets. So there should be a sequence from 0, 1, 2, 3 till W minus 1. Okay, packets should be numbered so that I can know, okay, which packets I'm expecting. Frames from a sender are numbered, and then what happens if you're numbering, I need bits to encode them. So maximum, let's say we allow m bits in our header. So for example, if I have m is equal to 3, so you can have sequence numbers 2 to the power of 3, which is 8. So I can have sequence numbers 0, 1, 2, 3, 4, 5, 6, 7. Okay, but if you have m bits for sequence, so you can have a range of 0 to 2 to the power of m minus 1. So for m is equal to 3, it says I can have sequence number 0, 1, 2 till 7. We can repeat the sequence numbers. Okay, so I can then repeat that. Okay, 0, 1, 2, 3, 4, 5, 6, 7. Then I can again start. Okay, so this is there. We will see this protocol in action now. So this is our sliding window. This is how it's much easier to understand. Okay, so it says that the sender maintains a sliding window. Okay, and this window has packets that have been sent but not acknowledged. Okay, so I need to have copy of those packets. So I sent some packet frame 3, it is not acknowledgement, so that will be there in the window. So those sequence numbers, and others will be there, the sequence numbers that can be sent but they are not sent right now. So if I have a window where I have numbers from 0 to 6, now let's say frame 0 and 1 are acknowledged. So it means these will go out of the window. So 0 and 1 comes out. This window slides. This means now I need to send frame 2, or frame 2 has been the last sent, the most previously sent packet, and now I can also send frames with numbers 0, 7 and 0. And if the window size at most is 2 to the power of m minus 1 if I have m bits, so let's try to see. And receiver window, receiver, what it has, its window is just size 1, which means that it says that okay, I'm expecting packet 0 now, packet with sequence number 0 now. It receives frame 0, then it will slide its frame window and say I need now frame 1. Okay, that's how. And if it is expecting frame 1 and somehow it receives frame 2, it will just discard that packet. Okay, now we have some control variables, because this is a picturization, I need to implement it on computer. So we have some control variables, SF, SL and S. What are they? S is the sequence number of the recently sent packet. Okay, S here means S is 0, I have just sent the last packet sent is packet with sequence number 0. SF is the starting of the window, which is the first unacknowledged packet. SL is the last frame in the window. And receiver just has one value, one element in the window, which is the frame that it is expecting. Others frame, if it gets, it will reject them or discard them. Now about acknowledgement. So here receiver only sends an acknowledgement, positive acknowledgement, that I have received some frame which is safe and in order, both. Okay, so in order, and so like it means here that it is expecting frame 0, then it should receive frame 0, not frame 3 or 1. Okay, that is in order and the same one. If frames are damaged or out of order, receiver is silent and discards all the subsequent frames. Okay, let's see again. So if I'm expecting frame 0, somehow frame 0 was lost, then because the window size, let's say it was 3, I sent frame 1 and frame 2 also, but I will silently discard them. I will not send any acknowledgement. This timer for frame 0 will expire and it will again send frame 0. Now if the receiver receives it, it will send ARQ 1, which means now you send again frame 1 and frame 2. So that's why it's go back n. Okay, Now the silence of the receiver, okay, because receiver did not send an ARQ, so the timer expires and all the frames sent after that particular lost frame are sent. So it resends all the frame beginning from the one for which the timer expired. We will see with example. So it tells one example. Suppose sender has sent frame 6. Okay, it sent frame 6, but the timer for frame 3 expires. So it had sent frame 3, frame 4, frame 5 and frame 6, and then it has not received the acknowledgement for frame 6. And what happens is, frame 3 the timer expires, then it knows that okay, the sender will assume that okay, nothing was, it has to send again all the frame 3, frame 4, frame 5 and frame 6. So it resends all the frame. And there is a concept of cumulative ARQ. What does that mean? Cumulative ARQ means that if I sent, let's say if F3, F4, F5 and F6 were sent, somehow acknowledgement for F3, F4 and F5 were not sent, but ARQ for F6 was sent and ARQ 7 was sent, then the sender will know that okay, it's a cumulative ARQ. It will understand that all the frames F3, F4, F5 and F6 have reached. Let's see some examples. Sender is there, so normal operation. Okay, I have SF, this is the window. SF and SL are the first and the last frames in it. S is the last frame sent. So S is 0 now, so I will send frame 0 here. Receiver window was just frame 0 here, it receives it, and then it does not send any acknowledgement. So because I have a window of size 3, I can send 3 packets frames without thinking of the bothering about the acknowledgement. So I sent frame 1 now. Frame 1 was sent, so this S variable will become 1 now because this is the last frame sent. I get an acknowledgement 2. So now what happens? I have got those acknowledgements. So you see here in this one now 0 and 1 are the frames for which I have not received any acknowledgement. So these are there in this particular window. So this part is for the frames for which they have been sent but the acknowledgement has not been received. So from SF to S are those frames which are sent but for which packets are not, ARQ is not received. This number is, I can send this, okay, but I have not sent it right now. So frame 2 ARQ 2 comes. Now because acknowledgement for 0 and 1 has been received, I slide this window further. So 2, 3, 0 now are there in this one. So I send frame 2. So S becomes 2. I get ARQ 3. So I will again slide the window. And here if you see, when it receives frame 1, so R is here, so it receives correctly. Now it is expecting frame 2, it gets frame 2, R moves to 3. So normal operation. Now let's try to see why the name go back N. So here I have M is equal to 2, which means I have a window of size 2 to the power of M minus 1, which is 2 square minus 1 or 3. So I can have 3 frames in the sliding window. So initially SF is 0, SL is 2 and S is 0. I can send frame 0. I send frame 0. Receiver's window was 0, so it is expecting frame 0. It got it. It slides to 1 to the right. Now it's not waiting for an acknowledgement. S becomes 1. I send frame 1 here. I get ARQ 2. So what it means, now these 2 packets comes out of the sliding window. Now S is at 2 and these are the sliding window. I sent frame 2 but somehow it was lost. But without bothering, I can send 2, 3 and 0 frames. I send frame 3. I also start a timer, okay, for the frames I have sent. So for timer for 2 was started. It was not received and I sent frame 3 but R was at 2. So it is expecting frame 2. It discards frame 3. And a timer expires. I again send frame 2 and it does not send that, okay, frame 3 for it does not send any ARQ. So I send frame 2 again and I get ARQ 3, so I send frame 3. So that's why it's go back n. So it means if I don't get acknowledgement for something, all the packets that were sent after this packet, they all will be resent again. So this is there, and you have cumulative ARQ. So even if I sent frame 1, I did not receive ARQ, F2, F3 I sent, and then I get an ARQ saying ARQ 4, then it is fine. So ARQ 4 will automatically mean F1, F2, F3 all were received properly. So this is about if an ARQ is damaged or lost. We have two situations. Okay, so first is if an ARQ is lost from the receiver side. Okay, so what can happen? A sender sends some frame, ARQ was lost. He sends another frame that was also lost, but he sends third frame and ARQ for this one is received. This also means that all the frames were received. Okay, and other case is I am sending frame, all the frames are getting received, frame 1, frame 2, frame 3, frame 4, but all the ARQs are lost. Okay, ARQs are lost, and then this, let's say, acknowledgement came for ARQ 5, but somehow the timer expires here itself. Then what will happen? Even though all the frames were received, F1, F2, F3, F4, they will be resent again. Okay, so that is being told here. So if the next ARQ arrives before the expiration of the timer, then it is fine because of cumulative acknowledgement. But so if ARQ 1, ARQ 2, ARQ 3 are lost, ARQ 4 covers them if arrives before the timer expires. But if the timer expires before ARQ 4 arrives, then all the frames are resent. So few things are good, but the thing is, if the channel is very noisy and lot of packets are lost, then this will have lots of retransmissions. So it's not that good in that case. So I hope you understand this. Thanks a lot.